to go, Brian. So yes, yep, you're good to go, Brian.
I'm going to do screen share. Can you guys see my screen okay?
And yes, yes, we can now.
Okay,
Yeah.
great. So, yeah, just make sure this PowerPoint comes up. Can you see my PowerPoint?
Yes, we can. Well, I can anyway.
Everybody else, can you see my PowerPoint?
Yes.
Okay, hopefully you can all see me. We're recording, okay? I'm going to stick very strictly to time because I want to do some live demo with you guys as well as part of this presentation. So I'm going to talk to you. I would ask you a question, maybe, I don't know if it's like if we can have a chat, but I'm just wondering how many people, you could maybe even say in the Slack, like how many people are making games with Unity right now? And how many people are using Unity and how many people are teaching Unity? Just be interesting. So what I'm going to talk to you guys about is porting one of my courses from Unity to Godot, which is a decision I made this year, and I'm going to tell you how I got on with that. So I'm going to tell you a bit about myself, first of all, to start, and this is not really to promote myself, but it's more just to give you the background to what like my experience in teaching and developing games, right? So I've been teaching in the School of Computer Science for 22 years. Been teaching games development to computer science students and to game design students for about 20 of those years. My PhD was in music information retrieval. So I developed software which is used by about 100,000 musicians around the world now for retrieving music scores from live queries of melodies played on traditional Irish instruments. So it's used by about 100,000 musicians, around 60,000 music searches a month go through that app. I teach at all levels of computer science. So I teach, say, transition year secondary school students from the computing academy, so from 15 years up. I teach on that workshop every year, and I teach game programming 1 to first year game design students, OOP to second year computer science students, and Game Engines 1 and Game Engines 2 to third year game design students, and fourth year computer science students. So I'm teaching everything right from TY students up to fourth year computer science students. I don't really make games. I don't make games, but I do loads of creative coding. And I make art projects with Unity Game Engine, or have been doing with Unity Game Engine with processing as well. I bring these to festivals. I'm going to skip through this very, very quickly. When I'm teaching, I want my students to get into a flow state. You might have heard of the term a flow state, but it's just this feeling of being completely immersed and free-flowing ideas and creative. And I think it's a really nice place to be when you're learning. And also, this is, for me, teaching is great fun as well. I mean, this is what teaching is all about. You don't have to teach, just open the doors and let the students do the creative teaching work themselves, kind of what I'm all about. I did mention about TunePal. Great, it's got 100,000 users, and I'm going to mention TunePal is not really relevant, but you'll see later how this actually ties into Godot Game Engine as well. This is Infinite Forms. Why I'm showing you this is because this was a big Unity project I worked on for maybe about 7 or 8 years, and this was a totally creative coding project. There's 600 commits on the master branch of my Git repo. There's hundreds of branches. You know, this was really my art project for many, many years. And it's a generative 3D environment. Everything is generated from code, and I made everything in it myself from code and from algorithms. I even did these quite sophisticated void simulations in Unity using the entity component system, which I taught in Unity for since 2017. So you might have heard of entity component system. If anybody's using Unity, it's this thing that Unity Game Engine had been promoting for many years as a way to do really high performance simulations. And, you know, where you wanted to have 20,000, so my simulations I coded had 23,000, I think, autonomous agents. They're called voids. And they were all implementing separate behaviors. They had procedural animations. This was thousands of lines of C# code that I wrote in Unity Game Engine. I took this project to a really cool Dublin night called Paradiso Party, which I'm happy to say is coming back on the 19th of August. If anybody's in Dublin, you guys welcome to join for that. And programmed live visuals. So I was with my Xbox controller with this project that I had made in Unity. It's responding to sound, taking inputs from the game controller, taking inputs from MIDI and so on. And I also was giving some talks about the expressive power of code and like how really, this is sort of almost like a psychedelic experience, coding in Unity. You can like, the example I always give is the octopus. I was out running and I had this idea for making an octopus and how its tentacles were going to move and animate. And then I came home and coded it up and put on my VR headset. And the next thing was an octopus swimming in front of me. So this is really powerful creative potential for game engines. And so I gave these talks about how coding was like a psychedelic experience. And I brought talks to Azora, the Cologne International Film Festival, to Republica, loads of other places. And I'm happy to say I'm giving a workshop at Mind and Psychedelics Conference in Berlin, all about building multisensory virtual reality experiences for neuroscientists and people investigating how the brain works and how VR basically can help to us to figure out how the brain works. So anyway, why am I telling you all this? Well, okay, here we go. Back. Change of pace. Game Engines 1, Game Engines 2. Right, so that's all the background. I wanted to give you that background, to give you the sense for like, I have worked deeply in Unity Game Engine for 8 years. Like this has been like my teaching, my hobby, everything, right? These are the two subjects that I teach: Game Engines 1, Game Engines 2. I'm going to skip over Game Engines 1. Game Engines 2 is the course I decided this year as an experiment. I would switch out of Unity and I would try something different, and I'll explain why. So this course is AI for game developers using Godot. It's now using Godot Game Engine. It didn't always have to be. This course I started teaching in C++ using DirectX and fixed function pipeline programming nearly 20 years ago. And this course has evolved. So I wrote my own game engine in C++ at one stage called BGE, which you can get on my GitHub repo. And this is what I used to teach the course for a good few years. Then I used XNA, and that was great. And, it's kind of like AI and emergence and flocking, and applications of linear algebra and applications of analytical geometry, how to calculate forces and stuff. That's a really fun course. So anyway, this is my use case in the classroom, right? So I do lots of in-classroom live coding with my students. I'm always coding my own personal projects and sharing them. I clone every year hundreds of repositories, GitHub repositories of my students' work. I'm opening up their work all the time. I want the students to use the game engine in the labs, and they also have to use it in class tests and in student projects, game jams, and competitions. For the last 8 years, that has been Unity. But this is the most important of all my slides. This is why I'm ditching Unity. Unity's gone. And I just can't do this anymore, right? This has been my experience of Unity for the last few years. So even after having investigated 8 years into it, like it's reached a roadblock for me when I really can't be creative and I can't teach with it anymore. And it's because of this. It's so goddamn slow now. You click the play button in Unity and like 7 minutes later, the thing pops open on the VR headset. And that's just not acceptable for me anymore, So I went through about a year of fighting, trying to get Unity to work well, fighting to try and get it installed in the labs properly. Very, very difficult. Licensing issues. Students, when I give them a lab test, maybe it would take them 10 minutes to open the starter code because they've done a slightly different version. So just so many problems. So that's it, Unity. After 8 years, goodbye. I'm not doing it anymore. I've discovered this great thing that I want to share with you guys because there is a solution. And if you're starting a new project, it's a research project, or you're starting a teaching project, you should be doing this instead. Again, I just give you all that background to give you kind of like, this is my own personal opinion, but it's based on nearly 20 years of seeing different trends come and go in industry, and this is the heads up. So first of all, Godot Game Engine, I've seen my students use it a few times. It's Unity-like. The editor is quite similar. It's about 100 megabyte download as opposed to like 5 gigabytes or whatever for Unity. It runs on everything from a Windows PC to a Mac and computer to even an Android smartphone. I'll show you a picture of it running on my Android smartphone. The actual game engine is written in the game engine, and So, it actually runs on an Android smartphone. You can actually do your game coding on a phone. It's great. Supports, it even runs in the browser. Supports everything from mobile to console to high-end VR headsets, high-end rendering, just like not quite at the level of Unreal yet, but very close to getting there. This is the amazing thing, and this is the joy of Godot. It has this cool language called GD script, and GD script is very close to Python. So it's quite a concise language. It's very, very easy for beginners to get their heads around. If you're teaching coding, you teach a GD script, and it's very like Python. When you see it, you kind of go, why does anybody use C# to write games? It's just such a big, fat language. It has these things called nodes. There's over 1,000 contributors to the Godot repo. You can watch the Godot talks at GDC, the Unity talks at GDC, and just compare, yourselves, and if you're making this decision. Show demo, right? I'm going to switch out here. Pause my slides for a minute, and I'm going to show you what the thing I made looks like. This is it, right? So this is, can you guys hopefully all see still my...
Yeah, we can see it.
Excellent. This is what Godot looks like. So if you've used Unity before, it looks like this. This is the thing I made, right? So this took me a semester basically to port my code over. Hopefully you can see this running. It's really cool. And it's such fun to play with these. Boys are great fun, right? So what I've got here is basically like there's 10 seeds I made, and they're implementing different behaviors for autonomous characters. These can be used in video games and movies. If you watch the Avatar movie, these are the algorithms used to simulate all the creatures in that. So this is, for example, the seek steering behavior, and I got 2 autonomous characters. All the vector drawing you can see here, the lines, the arrows and stuff like that, they're all to explain how the behaviors work, So you can see there's like a blue line and a circle. So I drew all those in, that's part of the thing I developed basically for teaching this stuff. This is a path following behavior, for example. So there's 2 autonomous characters here. There's also a little procedural animation. They're just following from one waypoint to the next. So this is another really cool. A lot of this is, I would say, transferable skills as well. These algorithms are computer science algorithms. So you're iterating through an array of waypoints. Once you get close to one waypoint, you advance to the next waypoint. So they're learning things like iteration and things as well. So let's see, we go here. Let's see, number 4. What's number 4? Number 4 are the 2 wandering behaviors. So you can see, for example, one of the things I was quite keen to make when I was doing this work was to make these really nice gizmos, right? So you can see how the behavior is working. This one's using Perl and noise, for example, right? And you can see that arrow that's projected in front of the void, and that's basically that's the Perl and noise calculating an angle which is rotating, and then the thing is rotating around. Trying to find that point. So then we got this one, and I wanted to link up. This is what I call a hybrid creature here. This is kind of like what my game AI course is about. It's about making these autonomous characters. And there's a lovely, beautiful creature that you can see swimming around here, is implementing avoidance behavior, harmonic behavior, constrained behavior, noise wander behavior, path following behavior. And you get this wonderful thing called emergence then when you combine these behaviors together. So emergence is when you combine the behaviors and they start doing these like sort of unexpected things. The nice thing about this is you can see literally like what exactly each behavior's impact is on the overall creature. So for example, I can do this here. We can press escape and I can adjust the distance that sphere gets projected forward. I can change the size of the radius like this. All this I developed from scratch in Godot, ported over a lot of my work this semester. So let's see the next one here. This is lovely. This is what's called offset pursue. So this is what you can use to simulate things like flocks and schools, things that always try to move in formation. All the little arrows and lines you see are drawn as part of, the simulation here, and they can be turned on and turned off in Godot. One very quick thing I'll show you. If you've ever coded in Unity, right? Watch what I can do here. Let me just see if I can find the void script here. What you can do, this is totally amazing. I keep one thing open at one window, and I keep my game open on one window. I keep Godot open on one window. So you can literally edit the code in the editor here. I think it's there's loads of keyboard shortcuts here, which I can't remember, but I just want to show you this, right? Like my game is running there in one window. If I go to physics process here, let's see, Okay, so I'll just really quickly edit some code here. Pause equals true. UUE, and I'm going to save my code. And then the game is updated live. Now, this for me, when I discovered you could do this in the game engine, after having years of fighting Unity, edit the code, click over, wait maybe a minute or two for Unity to like reloading assets, importing whatever. This was the game changer for me. From this moment on, I knew I could never go back to Unity again, right? Now that I have this expressive power for my thoughts on my code, and I can get it into the thing so quickly, I never want to go back to using any crap. I mean, literally, you know, BS tools ever again. Oh yeah, there we go. So I can unpause it. So I'm gonna go see that it's actually remembered the value of the variable from the last time. So if I go pause equals false like this, and you can put debugging code, you can put whatever in there, and there you go. Your game is updated live with new running code. Now that's Unity can't do that. Unreal can't do that. No other game engine in the world can do that. And from a teaching perspective, and from the use cases that I have, this is, you know, streets ahead of anything else that's out there. And hopefully you all can get onto it. So listen, let's show you the last one. So one of the great things about study of boys, right? The study of boys is really a very great computer science thing for people to study. So the reason why is because like you run into these like ON squared computational complexity problems. Like when you're trying to simulate in this one, now you're getting 23 FPS, like I normally get better. I guess it's because I'm streaming and stuff as well. But there's a lovely algorithm. If you've ever studied this field, called cell space partitioning, it uses various data structures like maps and things like that. So there's lots of very, very good computer science learning outcomes that students can learn. You can pause this simulation here, for example. Oops, if I press P, hopefully. Oh no, what's wrong with my keyboard here? P should pause. Oh yeah, because I probably edited the code to say pause is false. So I'm gonna hash that out there, press save, jump back over here, press P, and now I can pause the simulation. What you can see is, you know, this is an example of this boy is trying to calculate what are its neighbors, and you know, in an ON squared, it's got to calculate the distance between it and all the other voids in the scene. Whereas if you use this algorithm called the cell space partitioning algorithm, which you can see illustrated with these squares and lines and arrows, you can reduce it to ON because it only calculates its distance to the adjacent cells. That's a bit of a deep explanation, but it's lovely. And it's a really, really enjoyable for me to teach this kind of very deep computer science concept using this lovely tool, which is so expressive. That's my point. All right, so let it go there. And there we go. So this is, like I say, just a simulation of a few hundred. What else is in this scene? Is there anything else in this scene? Oh yeah, take control. This was my students' lab test this year. So for the lab test, what they had to do was they had to implement this behavior here, where you can go onto the back of the creature as such. This works in VR as well. You can take control of it then with an Xbox controller. And then when you press C, it's going to release the creature. Creature's meant to go back. I think it's C. No, Z. That's what it is. Press Z, and the creature's meant to go back to its little AI behavior. So that was my students' lab test that they had to do. That was like a 3-hour lab exam. So I wanted to show you what, like what I was able to make basically in one semester with Godot Game Engine. I'm going to jump back over here to my slides, leave some time for some questions. So that was Godot Game Engine. You guys hopefully can all see again. We're going to go back to the slides here. I might have to just duplicate my screen. Great. And you know when you do PowerPoint, like it goes into that presenter mode thing. So where am I PowerPoint here again? PowerPoint. Sorry, you guys. Did I close my PowerPoint? Oh my goodness, sorry. I'll let you guys watch the boys for a minute while PowerPoint loads. Okay, PowerPoint. Here we are. Great, excellent. So I'll jump on to right to the end of my PowerPoint here. Function F5. Skip forward. Apologies for this. Oh man, it's gone into presenter mode again. Sorry. Windows key and P. Switch back to duplicate mode. Or maybe you can see. It's probably okay.
We can see your PowerPoint now. Yeah.
You can
yeah,
see my PowerPoint. Yeah, my computer's just on a go. So I'll get to the last couple of slides here. Now it's actually what's going on here? I'll just get to the last slide. What the hell? Okay, I'll get to my last couple of slides. That was Game Engines 2.1, Game Engines 2. Duplicate. Can I switch? See, it's got this thing up here more. How do I make that thing go out of the way? You know what? Just in the interest of speed here, I'm going to run with PowerPoint. Can you see what I see kind of on the screen? Great. Can you see this picture?
Yes.
Great. Okay, great. Well, look, that's okay for me. This is a picture of John Romero. You might know John Romero is the inventor of the video game Doom. And this year I introduced Godot Game Engine to my second year students. I'm competing this thing called GameSpot. We do this thing called GameSpot for 20 years. And there were 2 Godot games this year, one of which won a prize, and my students got to meet John Romero. So that was really great. A VR endless runner game my students made in about a month using Godot Game Engine. Also, just relating back to TunePal that I mentioned earlier, shout out to Devin and Mason, 2 students who are currently working on porting the TunePal search engine to Godot Game Engine. So Godot can also be used to make apps. And these guys are doing a prototype, and we're hoping to do some testing with that in the university next week. There's a big music festival, traditional music festival. So these guys are working on porting Godot. We have everything, 23,000 tunes, the music, everything's got running on iOS, running on Android. And then finally, just some conclusions. My conclusions were that I want to get into a flow state. I want to be creative. I want to keep on doing these music projects. I want to keep getting my students to be creative. Unity is gone, mental health problems, everything, throw it out the window. People shouldn't put up with like waiting 2 minutes for your thing to appear on the screen after you click the play button. I mean, Jesus Christ, this is 2023. You know, we have to move on, dump Unity, find better tools, or like just even start using this thing and introducing people, and then maybe the Unity people will take notice and start like addressing the major problems with using their game engine in an academic context. For me, Godot has just been joyful. I've really enjoyed it. It's been a great learning experience, recoding all of this stuff again, using a new language. I found myself in my flow state a lot when I'm in the Godot game engine. I found Unity, whenever I even have to open it now, I feel sad. It hurt, you know, it's painful. So Godot, the opposite. I feel joy when I open it. There's a really great community around it. There's 1,000 developers working on this project. There's a Discord. There's YouTube videos. There's also great opportunities for people to start projects now in Godot and have a really big impact, because I think Godot's kind of like got an exponential growth curve. So, you know, that's my prediction. And just it's important to get buy-in from your students as well, because Unity still has a really big presence out there. And you know, a lot of people just don't consider it, that there is an alternative. And I want to say there is an alternative. It's called Godot, and it's almost like a dream. It's the dream game engine finally realized, and it's open source or free. So that's it, everybody. That was my experience using Godot. It's really like, this is more my own personal experience. I don't really have any statistics to report or anything. A couple of just final points. All of my code is on my GitHub repository. My course is on my GitHub repository. And anything else I want to say, I will put a blog post together with some very good references for people to follow up. If you want to follow up with any of this stuff from my talk today. I think I'm going to wrap it up there, and maybe there's about like 5 minutes for questions.
Thank you, Brian. Thank you so much.
You're welcome.
The first thing is, yeah, I found it quite interesting what you said, especially about the 2 engines. As a teacher, I've used Unity. I've been teaching Unity. I haven't taught Godot, but I've been using Godot for a little while as well, and I can see what you were saying. It's just easy. It's just very lightweight. You don't have much to wait. Now, GScript, you know, it's kind of Python. It's not exactly Python. It is a kind of a little mix, but I think it's still nice to use. It's kind of straightforward, and I like the way it is created. So yeah, I wouldn't leave Unity yet, but I think there is a place for Godot. And you say especially, I'm not sure if you mentioned it, but if you have a Raspberry Pi as well, you can do coding with Godot on your Raspberry Pi, which is amazing. So it's much more it gets gaming and programming more, I suppose, more accessible as well, which I like, because Unity, where at the beginning it was not that heavy, now it's quite heavy. So
it's ridiculous. It's like, as I say, it's like the main thing for me is I want something that my students are going to be able to be creative with, and also something that's a good fit for teaching. And I just don't think Unity has ever been a good fit for teaching. Like, again, those use cases, you know, having to clone hundreds of repos every year with like different versions to Unity, and then like having to wait, you know, minutes for the projects to open. The other thing then as well is like, even in lab exams, right? In lab exams, students may be having to waste 10 minutes.
You don't have much time, especially if you want to build
mental health load.
Yes.
You know, so there's all those issues that I think, from an academic side of things, I don't think we should be using it. Maybe if you want to make a commercial game, fine, you know, or you want to use some of the Unity back-end services and you have to use it or whatever. But, you know, by choice, I don't think it's something that you should choose to use. That's my feeling.
Yes.
That's my feeling from my journey.
Yes, no, man, that's valuable. So again, thank you very much for that. I like that, especially the AI bit. But so again, thank you very much, Brian, for this insight there. Now, you said that you might actually post some information and link, and it would be great, actually. So you can post them to me or in the Slack channel. If you want to post that there, it would be lovely. It would be great. Now, let me see if you have any questions there, guys. Any hands raised? Oh, no question. Okay. We still have 2 minutes, guys. So if you have questions, now is a good time to ask Brian about his experience of Godot.
The spaceships, are they cool? I mean, this is, again, I go back to joy. One of the great things about coding boys, boys are so much fun, you know, particularly when they start forming schools and flocks and they start doing, you know, from my previous project, when you combine the behaviors together and adjust the weight, sometimes they will do quite unexpected things.
You're talking about the emergence behavior.
The emergence is really interesting. Start doing backflips and all kinds of interesting emergent things. So there's a really great anthropomorphic quality. Next year, like I say, I hope to bring my students bird watching as part of the course, for a day. So we're going to sit in nature and observe the birds, you know, and how they flock and how they move. And then I'm going to try and get the students to simulate that.
Nice. I like it. I like your approach as well. Thanks very much, Brian. There are no questions here, so no questions to answer you. But again, probably because you covered a lot during your presentation anyway. So thanks very much for that. So we're going to move on to the next speaker. And again, you can stop sharing your screen there. I think, you can stop sharing your screen. And again, the next speaker is David Buster. So again, David, I'm not sure if you're here. You're here, yes. You can
I'm here.
your microphone. Fantastic, David. Welcome again. And you can start to share. I'm going to stop recording for now.